All right. So the 10-4, the ideal gas equation. Okay, so you can see I've got the variables up here listed out so you know what they are. So if you don't know what they are, if you're going to forget, I'd write those down. Remember, the temperatures must always be in Kelvin. Okay. The ideal gas equation is this right here, PV equals nRT. Okay, I call it, a lot of people call it, not just me, but call it PIV-NERT. So if you hear me say PIV-NERT, that's the ideal gas equation, PV equals nRT. P is pressure, V is volume, N is the amount or number in moles. R is the ideal gas constant, and T is temperature in Kelvin. Now, the R is a constant, right? I have given you, and that's what this page 402 is this right here. On those conversion sheets that I gave you guys, the ideal or the gas constant R, this is, they're all listed right here. Okay. So I believe we've talked about STP before. But if you've forgotten, make sure you make a note of this. STP stands for standard temperature and pressure. Standard temperature is 273 K, and pressure is 1 atmosphere. Okay. So relating the ideal gas equation and the gas laws. So the ideal gas equation is this equation here. If you are given 3 of the 4 things, you can figure out the 5th one. Okay. Now, when you are doing these problems, the ideal gas equation, how do you know which constant to use? Okay. That is based on the labels. You want the labels that cancel out to leave you with whatever the label for the variable that you're searching for. So, for example, say that you're trying to find the number of moles of something. So they give you pressure, volume, and temperature. Okay, how do you know which one of these to use? Well, the temperature should always be in K, so that's not really part. So if you look at the pressure and the volume, you want to find one that has the same pressure and volume labels that yours has. If it doesn't, you have to convert into something that are the labels here in the R factor. Okay, so for example, one of the first problem that I did walk through for tomorrow is one like this, and it gave me the volume in milliliters. So I had to convert the volume one. I had to convert the volume from milliliters to liters. So when I use this R, everything cancels out, and I was left with the label that I needed. Does that make sense? Okay. Okay, so relating the ideal gas equation and the gas laws that we just looked at. So all right. If we take PIV-NERT, PV equals nRT, the R is a constant, correct? So if we rearrange PIV-NERT to solve for R, we get PV over, gosh darn it. Almost did it again. PV over NT like this, right? Okay, now imagine we had 2 sets of like numbers. Like we've got P1, V1, N1, T1. Okay, equals R1. And we have P2, V2, N2, T2 equals R2 like this, right? Well, R is a constant, correct? So if it's a constant, it stays the same. So R1 and R2 are equal, which means we can do this. Everybody okay with the idea so far? Okay. Now, this thing is essentially the combined gas law. It's the combination of all those other gas laws, which is the thing that I highlighted right here in your notes. Okay. Now, how does it work? Well, if basically what you do is you take this and any variable that stays the same or doesn't change or remains constant or whatever, you can take that out. You can cancel it off of this equation because it's the same on both sides, right? And think about an algebra. If you have something like times 27 on both sides, you can just cancel the 27s because it's doing the same thing on both sides, right? So so watch what happens like here. There you go. Okay. Can you see both of those? Yeah, okay. So um, sorry. There we go. Look at Boyle's law. Boyle's law says the volume of a fixed quantity of gas. So quantity, amount, is which variable? N. It's fixed. It's not changing, correct? So we can just ignore it. At a constant temperature. That means temperature is not changing, correct? So we can ignore that. What are we left with? P1 times V1 equals P2 times V2, right? What's Boyle's law? P1 times V1 equals P2 times V2. So basically what you can do with the combined gas law is you can start with this always. Anything that is constant or doesn't change or whatever, you can cross out those variables, and whatever you're left with is the equation you should be using. So instead of having to remember or memorize, like 3 or 4 different laws, you can just use this always as your base one, get rid of any variables that aren't changing, and whatever you're left with is the equation you need to use. Does that make sense? Any questions? Okay. Now the last little thing is, does anybody have any idea of how we would know if we're going to use, based on like the problem, how we would know if we're going to use the ideal gas equation versus the combined gas equation? Any ideas? It has to do with what they give you. If you are given more than one amount of a variable, like if you're given 2 pressures or 2 temperatures or 2 volumes, like a beginning and an ending or a first and a second or whatever, you're probably going to use this. If you are only given one of each or one of everything, you're probably going to use this. Because to use the combined, you have to have 2 of at least a certain number of these, depending on what things are constant. Does that make sense? All right.